In this video, we're going to talk about what is a sequence and a series. A sequence is like a sequence of events. Something happens first, second, third, and so on. Or if you think of it in math terms, we have term 1, term 2, term 3. So it's a bunch of numbers separated with commas. The domain must be positive, and they must be integers. You can't have part of a term. And sometimes there are patterns to be found. Back in Algebra 2, you learned arithmetic sequences. Arithmetic sequences in Algebra 2 were linear. They were in the form of t sub n is equal to t sub 1 plus n minus 1d. In that case, d was what is known as the common difference. D is the common difference, and the first term in this particular formula is t sub 1. So back in Algebra 2, we learned if we have the sequence 3, 5, 7, 9, notice that the term's common difference is 2. The first term is t sub 1 is 3. And if we plug into the formula, we would get 3 plus n minus 1 times 2. That would allow us to find any term in the given sequence. We also learned back in Algebra 2 about geometric sequences. In a geometric sequence, the form could be t sub n is equal to a r to the n if the sequence is going from 0 to infinity, or it could be in the form t sub n a r to the n minus 1 if we're going from n is 1 to infinity. Now these sigmas are for series, not sequences, but we're just trying to get you a common background for this. So in my second example, I might have the sequence 24, 12, 6, and so on. To get the common ratio r, back in Algebra 2, we took the second term and divided by the first term. So in example 2, that would be a 1/2. Our first term, in this case, is 24. And if we were to plug that in, if we were going starting at 0 to infinity, our general term would be 24 times 1/2 to the n power. If we were starting at 1, it would be 24 1/2 to the n minus 1. Just try to remember that a is always the first term. The series is different because a series is the sum of a sequence and is denoted with sigma. Sometimes there are patterns, so a geometric series would be in the form sigma from k is 0 to infinity of a r to the k. Sometimes we use k, sometimes we use n, doesn't really matter. In a geometric series, the series will converge to a solution if the absolute value of r is less than 1, will diverge if the absolute value of r is greater than or equal to 1. If a geometric series converges, then the sum can be found using, I missed a g, the form, the first term divided by 1 minus the ratio. Now, when you're finding the first term, always, 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 how often? Always, use the lower limit to find the first term. So let's do a couple of examples of that. We have an example here where we want to find converge or diverge, and if the series converges, we want to find the sum. Well, so in this example, this matches our a r to the k form, where r is 1/2. Given that r is, absolute value of r is less than 1, because it's 1/2, then we can actually find the sum of this. So to get our first term, we're going to plug in a 0. If we plug in a 0 in for k, we get 3 times 1 is 3. So a is 3. Our common ratio is 1/2. So that would be first term 1 minus r, which would be 3 divided by 1/2, which would be 6. In the second example, again, we're in a geometric form, a r to the k. This time, r is 3/2. Well, when the absolute value of r is greater than or equal to 1, then the series diverges. So we had one converge and one diverge.